Okay, today we're going to do 6.1 to 6.3 pre-quest number 1. And note that right at the very top it says round to the nearest hundredth, so that's what we'll do throughout anything that needs rounding. Number 1, given a couple of points. In the most basic of all problems, we are finding the coordinates of vector mn. So from m to n, the coordinates of that vector are 3, -1. From -2 to 1 is +3 steps, and from 3 to 2 is -1 step, or 1 minus -2 and 2 minus 3. Those are the coordinates or the components of vector mn. Now, for the next set of problems, we are to use this given. So we've been given a couple of vectors now, v and u, and we're going to do some stuff with them. So here, the first thing we're going to do is v dot u. This is number 2a. We're finding v dot u. So when we do a dot product, remember it's x times x, y times y, and add them up. So that's 3 plus -8. So the answer is -5. Remember, the dot product of two vectors is just a number. So the answer is -5. X times x, y times y, add them up. Okay. I'll leave this here. This is our given. So this is what we're using for this set of problems. So B is 2v minus u. Okay, so we're going to take 2 times v. Okay, so 2 times v will be 2 -4. Remember, when you take 2 times, or anything times a vector, you just multiply it times both pieces. And then we're going to subtract u, which is 3, 4. So when we subtract, we take x minus x. So 2 minus 3. And then y minus y. -4 minus 4. Watch the arithmetic. That's -8. So your answer is -1, -8. C says find the magnitude of v. Now remember, the symbol, the absolute value symbol, means magnitude. And to find magnitude, you simply square the first number, square the second number, add them up, and take the square root. Magnitude is super simple to find. Square the first number, square the second number, add them together, and take the square root. When we first started doing this way back at the very beginning of the unit, we were drawing a picture of the vectors and doing the Pythagorean theorem, but we just noticed that pretty soon it's just x squared plus y squared, the square root of that. That's your magnitude. Okay, D says we're going to add v plus u. So that's 1 -2 plus 3, 4. We're just adding those. So super simple. Add the x's, 1 plus 3. Add the y's, -2 plus 4. And there is your sum, otherwise known as your resultant. When you add vectors, talked about this one day, the vector word for sum is resultant. Okay? Lots of parts to this question. The next part, E, says v minus 3u. So this is another magnitude problem. See the absolute value. But we got to do what's inside first. So we're going to take v minus 3u. So there's v minus 3 times u. So 3 times u is not 9, 12. Now we're going to subtract those. So when we subtract, we do x minus x. Oh, I have the hiccup, sorry. X minus x. And then y minus y, which is going to be negative 2 minus 12, which is negative 14. So x minus x and y minus y. Now, we still need the magnitude. So to do magnitude, we square the first one, square the second one, and remember, use your calculator if you need to. Add them together and take the square root. So it's the square root of 260. Now we need to break that down. So let's see, 260 is 26 times 10, which is 2 times 13 and 2 times 5. So we can take a 2 out, so that's going to be 2 root 65. Take a 2 out, and then you have the 13 and the 5 left over. So that's the answer to that question. And then the last one in that list is u minus v. Now be careful, it is u minus v. So it's 3, 4 minus 1, negative 2. It's the u vector minus the v vector. So again, we just subtract x minus x, so 3 minus 1, and then 4 minus negative 2, 4 minus negative 2. So your answer is 2, 6. So that takes care of all those kind of basic operations with the vectors there. Okay? So now we're ready to look at problem number 3. So I'm going to erase all this now. And we're going to go with problem number 3. Sorry about these hiccups. All right, so they give me 2 points. And they asked me to find the components and the magnitude. Now, the components, remember, just the directed distance. You already did a problem like this. It's just like problem number 1. We just want the directed distance. So from negative 2 to 4 is 6. And from 1 to 5 is 4. So there are the components of that vector. So again, 4 minus negative 2, 5 minus 1 if you want to do it that way. Now magnitude, the first one, square the second one, add them together, take the square root, and then simplify if possible. So that's 2 root 13 for the magnitude. Kids, that's easy. You've done a lot of that. That's easy. Okay. Then the last one on the first page, number 4, says you have a vector that looks like this. And you have to find the components. So again, we are finding the x and y. Okay? Now, there are a couple of ways to do this, but if we do it the way that we have been, we stay consistent with what we have been doing. We've been dropping a perpendicular down here, noting that this is x and this is y. I'm going to move my 16 out here. And we have a right triangle so that we can say cosine of something and sine of something. We can do cosine and sine. Now, what makes this problem a little bit different is we don't know what this angle is. In our other examples, we were given that angle. But I hope you're not freaking out, because can't you find that angle? I think you can. You know that if you went all the way to here, watch my finger, if I went all the way around, it would be 180. So if this is 115, doesn't this have to be 65? Because 115 and 65 would give you 180. So we can say cosine 65 equals x over 16, because cosine equals adjacent over hypotenuse, and sine 65 equals y over 16. Then we can multiply by 16 to get rid of the fraction, get our variable by itself, and then just type it in on the calculator. So 16 cosine 65. For x, I got 6.76. And 16 sine 65. For y, I got 14.50. Now, if I do it this way, which is the way we've been doing it, and it's consistent, and it's absolutely fine and beautiful, you do have to pay attention to something. See this x right here? He has to be made negative. He has to be made negative because he's in the second quadrant. Here are the components of that vector. Okay. All right. Now we are ready to go to number 5, which gives me two vectors. And we're going to find the angle between them. So we're going to find the angle between. Okay, so if you recall, we have a little formula for this. The formula says that the cosine of the angle, not the angle itself, but the cosine of the angle, is the dot product of the vectors divided by the magnitudes times each other. So, first thing we have to do is find our dot product. All right? So our dot product, remember, is x times x, y times y, added together. So -2 plus 20, which is 18. So my dot product, x times x, y times y, add them up, 18. Now I'm going to divide that by the two magnitudes. And I know they're radicals because magnitude, remember, we square the first, square the second, add them together, and take the square root. So now we're going to find the magnitude of vector v, which is going to be 4 plus 16. So the magnitude of vector v is root 20. Don't bother simplifying. Please don't. It makes it easier if you don't. Just leave it alone. Remember, this is not going in the answer blank. This is the cosine. You have to find the angle. All right, vector u, magnitude. First one squared, second one squared, that's going to be root 26. Now, I would suggest, and I have all along, that before we type this in on our calculator, we go ahead and multiply those two together. So instead of having two separate radicals, we're going to have one. 20 times 26, so it's the square root of 520. And then to find theta, we're going to second cosine, because it's cosine theta, so we have to second cosine 18 over the square root of 520. So second cosine 18 divided by the square root of 520. 37.87 degrees. So the angle between the vectors is 37.87 degrees. This little formula right here, you got to know. That's how you're going to find the angle between two vectors. So you know how to do the dot product, you know how to find magnitudes. So as long as you know the formula, you're all set. To find the actual angle, we have to second cosine this fraction. Okay. All right, now we've got a couple of parametric equations. All right, so I want to make sure I've got that right. Now remove the parameter and write one equation. Well, I like the way this was written in our notes better, because in our notes it literally said eliminate the parameter. And using the word eliminate kind of gives you a hint of the process that you can use to do this. We need to eliminate the t's. We need to get rid of the t's. So that's easy. You all know how to eliminate. To get rid of the t's, we could multiply the top row by 2. So we would have 2x equals, 2x equals 4 plus 2t, and then y equals 3 minus 2t. And now we're simply going to add these together. So I took my top equation times 2. Now I'm going to add them together. Now when I add these, it's 2x plus y. You can't do anything with that. It's just 2x plus y. These you can make a 7, and those are gone. Your job was to remove the parameter, it's gone, and write one equation, there it is. That is all there is to it, you guys. That is it. Done. Okay. Now the next problem is sort of the same thing but backwards. Because now you are going to write the parametric equations. So you know those equations that we started with in the last problem, like x equals 2 plus t and y equals whatever? Those were parametric equations. You're going to come up with those now. So if you remember, we haven't done a lot of this, but if you remember in the notes when we did this, we started by writing, let's see where I have room to go. Let me erase this. This is our goal, just come up with this. Okay, so we started by writing an equation that looked like this. So you have x, y always. This is always the format that you're going to start with, okay? These are commas, okay? Now, in this first blank, you pick one of your 2 points. It doesn't matter. Now, obviously, if I pick this one and you pick that one, our answers are going to look like slightly different. Well, they're going to look different. But that's okay. I will know that when I grade your paper. Anybody else will know that when they look at your paper. It's okay to have answers in different forms. I'm going to go ahead and use the first one. Now here, this is where we've got to be careful because the temptation is to put that there, and that's wrong. You need to put the vector from here to here in there. So in other words, you have to put the directed distance from here to here in there. Another way to think about that is put the slope in here. So if I do it in terms of a vector, which is how I do it, 1 to 3 is 2, and 2 to 5 is 3. But if you do it with slope, because that's a concept more familiar to you, y minus y over x minus x, and your slope is 3/2. The only thing I caution you about is if you do it this way, remember slope is y over x. So when you put those numbers into this parentheses, this has to go on the y spot and this has to go on the x spot. You can do it either way. I think of it as the vector. You might think of it as the slope. Either way is perfectly fine. Notice we got exactly the same answer. Now, to write the parametric equations, we look at the first part of every parenthesis. There's 3 parentheses there. X equals 1 plus 2t. And then we look at the second part. Y equals 2 plus 3t. Remember, this t goes with both of those. And there are your parametric equations. Easy peasy. Okay, now we're going to find the components of the velocity vector for an airplane flying at a speed of 362 miles an hour on a course of 128. So when I see that I have an airplane flying or a ship sailing or whatever, I'm using my compass. And we are on a course of 128, which would put us down here. This is 128 degrees. And a speed of 362. So remember, the speed is the magnitude. That goes right there. Now your job is to find the components. Guys, the components are x comma y. So we've done this before on this very paper. To find the components, we make ourselves a right triangle. This is x, this is y, and we're going to set up a cosine equation and a sine equation. Now, we'd be all set if we knew how big this angle was. We need to find this blue angle right here. Now that is easy. If you just think about it for a minute, the whole black angle is 128. This much is 90. So you have 90 plus some extra to get 128. So what does that extra have to be? Well, we're just going to do 128 minus 90. So that's a 38 degree angle. That blue thing is 38 degrees because 90, a quadrant is 90. So 90 plus 38 would give me the 128. So then I have my equations. Cosine 38 equals x over 362. And sine 38 equals y over 362. So then we'll take 362 times cosine 38 and 285.26. And then 362 times sine 38, 222.87. And then what do we always have to think about when we're starting with a picture and we're finding x and y? We have to pay attention to the quadrant that we are in. So we are in quadrant 4, which means our x will be positive, but our y must be negative. Okay. So far, so good. Now we have a vector, 5, -1, and we want to make it a unit vector. Well, that's easy. Do you remember how to make a unit vector? To find a unit vector, you are simply going to divide each of these coordinates by the magnitude of the vector. Well, what is the magnitude of the vector? Well, we square the first one, square the second one, add them up and take the square root. So the magnitude is root 26, which means your unit vector is 5 over root 26, comma, negative 1 over root 26. Done. To find a unit vector, you simply take the coordinates of the original and divide by its magnitude. Number 10. Have another vector. And this time we are finding the magnitude again and the direction angle. All right, well, magnitude's easy. We can do this with our eyes shut. Square the first one, square the second one, add them together, and take the square root. So you obviously can use a calculator if you want to check your arithmetic or whatever. That's it. That's the magnitude. Now, the direction angle is a little bit more complicated, but not a lot. I would suggest we draw a little picture. So over 4, down 7. And anytime we want the angle, and remember that the angle that we want is going to be this one. That's the angle that we want. The red angle is going to be our answer. But we're not able to find it because it's not even in the triangle. So we're going to make our little triangle, and we're going to find this angle right here. I'll call it theta. That's what I've been calling it. That's the angle I want, right there. Now, I know that this is 4 and this is 7. That was given. So I can tell from that picture that the tangent of my angle is 7/4. Tangent is opposite over adjacent. Remember, x is always adjacent, y is always opposite. So the angle will be found by doing second tangent. Since it's tan theta, and I need just theta, I have to second tangent. So I'll second tangent 7/4. And I get 60.26. So this angle is 60.26. Now, if we have a test or quiz, some of you are going to say 60.26 as the direction angle. And of course, I'm going to have to count that partially wrong because we really need the red angle. The red angle is the direction angle. The direction angle must be measured from the positive x-axis. So, how can I find that red angle? Well, just think about it. Use your logic. All the way around is 360. We didn't make it all the way around. We stopped here, which meant we still had 60.26 to go. So 360 minus 60.26 gives us our direction angle, which is 299.74 degrees. That is the answer to the question. 360 minus 60.26. Okay, now we've got a couple of vectors. I'm looking at number 11 now. So v is 3, 1, and u is -6, -2. And your job is to tell if they are parallel. Well, I'll use the symbols. Are they parallel? Are they orthogonal? Or neither? And if you remember when we did these in the notes, it was really easy. When we did them in the notes, we just found the slope of each vector. So the slope of vector v is 1/3. And before you say, how do you do that? Stop. Remember, this says this vector is a movement. it's going right 3 and up 1. Well, isn't slope rise over run? So the rise is 1, the run is 3, the slope is 1/3. This slope is -2 over -6, y over x. Slope is y over x. Well, that reduces to 1/3. The slopes are the same, which means these vectors are parallel. If the slopes are the same, your vectors are parallel, just like lines. Lines are parallel when they have the same slope. Okay, one more problem on this page, and then I'm going to do a couple practice quizzes too. So, got a whole bunch of points here. A is 1, 3. B is 4, 7. C is -2, 1. And D is 5, 3. Okay, so the question is, we want to know if AB is equal to CD. Is that true? Are they equal? Now, we can't answer the question until we find the coordinates. So let's go ahead and find the coordinates of each vector, and then we'll know. Because if these are the same, then yeah, they are equal. If they're not the same, then no, they are not equal. So what are the coordinates from from point A to point B? 1 to 4 is 3, 3 to 7 is 4, or 4 minus 1, 7 minus 3. There are the coordinates for vector AB. Now, what about from C to D? From -2 to from -2 to 5 is 7, and from 1 to 3 is 2. Oh, wait a minute. I think I copied this wrong. I'm so sorry. I copied that wrong. C is 2, -1. Did you catch that? I'm so sorry. I'm so sorry. All right, let's try again. Now I have the right point. So 2 to 5 is 3, and -1 to 3 is 4, or 5 minus 2 and 3 minus -1. Wait a minute. They're exactly the same. Are these equal? Yes, they are. Why are they equal? Because their coordinates are exactly the same. Okay, now I'm going to go ahead and do practice quiz 6.2 and the makeup vector quiz. These two are in your in-Schoology PDFs. You can either get the handout, do them in Notability, or print them out, or you can just write down what I'm about to do here. But this is just some extra practice for us. We'll get these done. Okay, so that was it for Practice Quest 1. That is done. Practice Quest 1, we finished it. And I'm putting on now these quizzes. So this is quiz 6.2. And we're given the vectors -2, 4, and 1, 2. Now, you might notice that on this particular paper, I have used this notation for vectors, and that's used in a lot of books, and this is an old quiz, and that's the notation that the book was using. Don't be alarmed. It's the same thing. Please don't let it bother you. These are two vectors. The first thing you're going to do is find v dot u. Again, we're just reviewing. Great practice. V dot u means take x times x, y times y, x times x, y times y, add them up. So the dot product is -2 plus 8, 6. The dot product is 6. Now we're going to find the angle between them. And our formula says that the angle between them is the dot product, which, oh, by the way, we already know is 6, divided by the magnitudes of the two vectors times each other. So we need to find the magnitude of V. The magnitude of V is the square root of 4 plus 16, square root of 20. Remember, we square, add them up and take the square root. U, 1 plus 4, square, add them up, take the square root. This is the magnitude of U. So that's 5, square root of 5. Now, when you, I suggest you multiply those together and make it the square root of 100, which you know is 10. Simplify it or don't simplify it. It doesn't matter because you got to find theta. That's not theta. That isn't the answer. I know that's 3/5. Simplify it if you want. I don't care. I need to find theta. And how do I find theta? I second cosine that fraction. So I'm going to second cosine this, or this. It's all the same. Makes no difference. Second cosine 3/5. And the answer is 53.13 degrees. That is the angle between those two vectors. All right, we're going to practice one more of those because there's another one there. Same exact question, but different vectors. So this time our vectors are 4, -2, and 1, 2. And we're going to find the dot product. So again, we take x times x. We take y times y, and we add them up. So that's 4 and -4. That's 0. What do we know when the dot product is 0? We know the vectors are orthogonal, which means the angle between them is 90 degrees. I'm not even going to do all that other work. I don't need to do all that other work. The angle between these vectors is 90 degrees because the dot product, x times x, y times y, add them up, that turned out to be 0. And when the dot product is 0, the vectors are orthogonal, which means they have a 90-degree angle. Orthogonal, remember, is the vector word for perpendicular. Another one of your vocabulary words. Okay, turn the page. Just a couple more problems and we'll be done. I know this says makeup vector quiz at the top. It's in the same PDF file as the one we just did. So first question says find AB. Oh, magnitude of AB. Find the magnitude of AB. Okay, so first of all, let's find AB. So -3 to 7 would be 10, and 1 to 4 would be 3. So again, 7 minus -3, 4 minus 1, if you want to do it that way. Those are the coordinates of vector AB. So the magnitude, square the first one, square the second one, add them up, and take the square root. So the magnitude is the square root of 109. I'm going to skip down and do number 3 because it uses the same 2 points. And I won't have to write them again. So I'm skipping down. This is going to be number 3 now. That was number 1. So here's number 3. We're going to write the parametric equations. So that's where we're writing x equals and y equals. That's what we're looking for. So remember, we start with this idea of the vector equation of the line. So it looks like that. And in the first parentheses, we're going to put either one of these 2 points. I don't like messing with negatives, so I'm going to put 7 and 4. But you can put -3 and 1, makes no difference. Put one of the points here. Now remember, what goes here is the slope. So if we're going to find the slope here, we're going to say our slope is y minus y over x minus x. So y minus y, that's 3, over x minus x, which is 10. Now, when you fill it into that parentheses, though, remember, this is y over x. So y goes here and x goes here. Oh, does that look familiar? Heck yeah, that's the direction vector for AB. That's what we got in problem number 1. The direction vector and the slope are the same thing. You just have to make sure you know which one's x and which one's y. Okay, so now I can get my parametric equations. I'm going to match up all the first parts. So x equals 7 plus 10t, and y equals 4 plus 3t. And there are your parametric equations. Remember, we match up all the first parts, and then we match up all the second parts. All right, 2 more questions. We've got vector v, which is, oops, I keep messing that up. Vector v is 3, -2, and vector u is 1, 5. And the first thing we're going to do is find the angle between them. We're going to find the angle between these 2 vectors. So we've done this a couple of times already. To find the angle between 2 vectors, we have a formula that says the cosine is the dot product, over magnitude times magnitude. Okay? So let's do our dot product. Our dot product is x times x, so that'll be 3. Y times y, that'll be -10. Add them together, the dot product is -7. X times x, y times y, add them up. 3 plus -10. Now we need to do our magnitudes. So there's going to be a couple of radicals down here. So the magnitude of v, we square the first one, square the second one, add them up, that's root 13. U, square the first one, square the second one, add them up, that's root 26. Before we go to the calculator, or at least before we find the angle, let's put those 2 together. So 13 times 26 is 338. So instead of having 2 little radicals down there, I have 1 big one now. It makes it easier to type in. Because to type it in, I'm going to have to second cosine that fraction. So second cosine -7 divided by the square root of 338. 112.38. So theta is 112.38 degrees. Again, this formula is critical. You all know how to do a dot product. You all know how to do magnitudes. So you just got to remember the formula, and then you second cosine that fraction. All right, 1 more, and you are done. Using these same 2 vectors, we're going to find this. So again, we think of these, this is magnitude. We're going to be finding magnitude, but that's the very last step. It's kind of like parentheses. We have to do all this stuff inside. So we're going to take 2v. So 2v would be 6 - 4. remember, when you do 2 times, you take the vector, you take 2 times each piece. We're going to subtract u. So we're going to figure out what this is. This is 2v minus u. So 6 minus 1 is 5. Negative 4 minus 5. Negative 4 minus 5 is negative 9. Negative 4 minus a 5. And now we have to find the magnitude of that. So we did 2 times v minus u. We figured out what that was. Now we square the first one, square the second one, add them up and take the square root. So that's the square root of 106, which I don't think breaks down because 106 is 2 times 53. So the square root of 106 is the answer to the question. Good work.